mat, it's easier to explain it like this. If you take a force extension graph, that's your force, or your load, the amount of masses you put on it, and your extension, how far it stretches. For a helical spring, so for a spring that looks like that, it will follow Hooke's law for quite a long time. That means that as you add a force, it extends by the same amount each time you add the same force. And then eventually it'll become permanently stretched and you'll have an elastic region like this. So that's for the spring. For the metal wire, it's much harder to stretch the metal wire, much harder. So because it's harder, your graph is going to be steeper, meaning for the same extension here, you need a much bigger force. So you're going to have a much steeper graph, and then the wire will just snap. So there won't be a large elastic region, like a plastic region like this. There won't be a large plastic region. It will just brittle and snap like that, and that will be the end of it, the metal wire. It will stretch and then it will snap. For the elastic band, so this is the wire, the elastic band, like a rubber band like that, you'll have the force of the extension graph. Now, what that will need is not a very big force to stretch it for the same extension. So it will be much shallower than this graph up here. So it will be much shallower like this. So it needs a small force to extend it a small distance, but it'll have a really large elastic region and a very small plastic region where it will be permanently deformed. So they sort of look like that. So what you'll be asked for in the exam is to judge by how big a force is needed to stretch it by how big an extension. Hope that helps.